Hello, community! I got some questions. Hey, with the new Adobe AI coming out, Firefly, Photoshop AI, generative fill-in, do I really have to pay to have access to this technology? Or do I have an option that I can use this here if I know to code a little bit? So today we go, hey, is there an option, a free option for Stable Diffusion XL effect? Where are we today? So here we go. Now, second week here in September 2023. This is my day 4 of exploring here Stable Diffusion XL. You will see only AI generated images and the cost were exactly 0. I have no NVIDIA GPU on my laptop. So I completely rely on free web resources. And as you can see, I use ClipDrop by Stability AI, and yes, they want to lure you into their product, but they have a free demo, so why not have a look what is possible on the technology for free, or do you have to pay Adobe? So here we go. This is, for example, an image that took about 4 to 6 seconds to compute. It is an absolute synthetic image generated by Stable Diffusion XL, Stability AI, and of course it's not copyright protected. As you can see, we have some beautiful bokeh effect. We have here a background that has been blurred. You just define here the image with your own words. In English, you write 2-3 sentences into the input prompt, and given how clearly and how specific you define the image, the AI system generates this synthetic image. Interesting. Now, I made a mistake that I thought, hey, I want a perfect image. I want a perfect symmetry. I want to have here my dream image of whatever I was dreaming of. And then I looked at here the other YouTube channel here from, I like the late Peter McKinnon, when he decided to quit with digital photography. Some interesting ideas here by Peter, or First Man Photography. He loves photography. This is unbelievable, the emotions and the days he spent out there in rainy England just to take a picture of a landscape. It conveys emotions. Or I have here 3 other channels that each on its particular way are interesting for me. So we generate here a synthetic image. Is it beautiful? Is it what you want? Is it okay for September 2023 for €0? Let's have a look at this. As you see, each of the poses of our model is different because we do not specify here the exact pose that we want to have our model in. We could do this, but we are operating here on the base model on ClipDrop, so I have no way to tell the computer what I want, just the very basic version. But I think it also starts to convey emotions. Even here, the tiniest, smallest Stable Diffusion XL model, without any modification I can do or any improvement I can add on, it already gives some really interesting images. Now, you see that here, for example, in Automatic 1111, when we use here text-to-image creation, where I told you in my last videos about the functionality of the refiner model, a complete independent second model just there to optimize the face, the proportions of the face, the clarity of the face, the beauty of the human eyes. I have not access to the refiner in the base model here if I go here with the demo of Stability AI, but you can clearly see that here a refiner would be needed, and this is why we have a refiner model. So I know it is here difficult and it adds a lot of memory to your GPU requirements, but it is really, really useful. And in the second half of the video, I'm going to show you here the examples of the ControlNet, not of the mighty ControlNet, not of the reduced ControlNet LoRa, but of the really tiny little just text-to-image adapters that do a little bit of ControlNet. So let's go on. An image, as I learned from the late Peter McKinnon, is also about composition. And you guessed it, I'm not a photographer. And you can really design your background in a very simple but interesting way, where you can define if you want to have some light on which portions on the background. You can experiment with this. And finally, I think it is really true. It is not about a perfect image. Look here, I don't know, in your eyes here you see there's a little bit of too much of a black shadow right here. Of course you can go in Photoshop and correct this, but why not? It makes the imperfections in a face what's the real beautiful thing. So interesting that here also the AI computation show us imperfection, but of course if you would use the refiner model, their eyes would be absolutely perfect, symmetric, and beautiful. Now, I got some questions from my subscribers who said, hey, is this computational photography? No, it is far beyond computational photography. Because if you take an image with your new iPhone or with your new Android phone, you take a real image and then you have some AI mechanisms optimizing the real image that you have taken with your camera. Here, I have just a computer model, an AI model, and my input sentences. And in this model, millions and millions and millions of images have been trained on. And I have here a complete synthetic image. There's nothing done that I took this photo. Great. As you can see, we have problems. Problems with hands. The face and the hands are always the problems area. And here you can see that the hand suddenly disappears in the body. And also here, the form and the shape of her fingers. There's something strange going on here. So we need refinement models. Otherwise, sometimes the base model also produces some very nice images. But remember, it is a text-to-image AI model. So the better your verbal textual description, what image you want to generate, the foreground, the background, the transition, the object, the color, the pose, the way of interaction, the mood of the photo, the material that you want. The better you have the textual description, the better you will have here the image, because you remember, in the training phase, you always had an image taken by a human and the meta information right under the image that describes the scene of the image, what is happening in the photo a human took, or if it was done by a computer. This model, I think, borrowed some images from the internet, and then we had an AI machine that analyzed an image that had no meta information attached, and the AI system was trained on image segmentation, object identification, and we had an LLM writing some text, some informational text about these specific images. And if you do this 1,000,000 times, 100 million times, you get a data set for stable diffusion models. Great. Yeah, as I told you, I use here the open clip drop. Go to this website and you create these images, because this is the worst case, because I created this. So you can got worse than me, because I'm just on day number 4, and you have a specific amount of very limited free images that you can create with zero amount of dollars or euros. Great. Now, some questions were about how is this image generated by a computer? Now, you can go back 2-3 videos and explain exactly the stable diffusion process for you, and we code this in detail, but very short explanation. We write some code to generate a synthetic image. And the model, the AI model that we're gonna use, has been trained on millions and millions of real photos and on the meta description of these real photos. So we construct a vector space of the textual description. You notice our LLM, for example, in tokenization, and an image encoding. This is the famous clip encoder, if you remember. And then when we created here a mathematical optimized space where we have a compressed representation to do the computation of our vector embeddings of our text and the vector embeddings of our images in this joint embedded space of text and image, we can build an architecture, an AI architecture of transformer blocks here, a UNet, or you use convolutional networks. And in this UNet, this is the perfect architecture for some noising and denoising, and the mathematical operations here when we use denoising is a diffusion equation from theoretical physics. And remember, mathematics found numerical approximation to a stochastical differential equation. And solving this, not the perfect analytical form, but solving this on a numerical, almost perfect done approximation, then this compute stochastic differential equation solvers give us here the beautiful combined images of our elements that we defined here in the input prompt, and the image is generated by stable diffusion models in the Latin space and converted back into the pixel space. This was the 1-minute explanation what's going on here. Great. Sometimes the hand almost are okay, but as you can still see here are some minor imperfections. But as I told you, it is not about perfection. It is not about a perfect image. And I think it is those little tiny imperfections that create real beauty. Of course, you could increase then the compute time to 10 seconds or even more. But we still use here the base model, no refiner. So we go here with the simplest model that you can think of. And let's do some experimentation. And just remember, it is all about the data the model has been trained on, and your input text description, what you want to see in this synthetic image. The better you are, and the more your verbal text descriptions is a professional description by a professional photographer who knows exactly how to address the topics and knows what are the right technical terms to describe an image. As a photographer, you have a significant advantage over simple persons like me. Okay. Nice. You can go back in time and create images really of, I don't know, the ancient Rome 2000 years ago, how it might have looked like. Those stable diffusion models, if you have a precise descriptions, have depictions or have drawings or whatever, enough material to synthetically generate scenes from all the different centuries. As I told you, you can play with the depth impression. You see the foreground here is completely out of focus. Then we have the face in focus and the background is again out of focus. And I showed you with ControlNet, so some additional element now to Stable Diffusion XL, we can define where is here the manifold that is sharp. What is the region that I want to have really as a sharp one, and then the computer should blur the rest. As I told you, I don't think it's about facts, even in synthetic image generation, but it is about feelings. That's at least what I think. And as always, it is also about our human impression. And if you look at these eyes, there is a little bit tiny wrong with this image. And I think it's here that the eye is not perfectly round and there's a light reflection. Hey, there's a light reflection here that it's not the perfect symmetry. If you have a symmetry axis, I don't know, something is a little tiny bit off here with the roundness of this eye. If you look really close, you see you need refinement models that have been trained only on let's say, the perfect human face. So if you want here a studio photography, if you really want to come close here, you need this additional refinement model to get here symmetry. And we as humans, we are really sensitive to these details. And I record this here on a 4K screen, so I don't know if about the YouTube compression algorithm, but depending on which device you watch this, you will see here with a high resolution, you notice there's something off here with this picture. Of course, I think even with the base model, you can create the picture or the photo of your dreams. So I think technology today, if you can code, if you understand what's going on, how this model works, what elements you can combine, how you have to formulate something, it helps you a lot to create those images. But remember, it is always about our human projection, what we want, the patterns we have been brought up with, in what region of this beautiful world you are living, on which continent of this earth you have been brought up, which values you have, which patterns you are used to, which perfect beauty projection you have encountered in your childhood. All of this will have here an effect on the projection and the judgment when you look at images, if they move you, if you feel something, or whatever. The perfect dream world. So let's do something. Second part, ControlNet. Now, to the base model, we have now an image. You can take an image from your iPhone or your Android phone, or I take here a reference image, and this is an image I created with ClipDrop, not sponsored, unfortunately, but take any image, synthetic, real, whatever. And this image is our reference image, and now we modify parts of the image. I want to show you, or let's explore, can we do this, or do we need Photoshop AI with all the different levels and all the different manifolds and all the different whatever? Or can we just do it with artificial intelligence, with our human words, with our human sentences? And we just say, hey, I want this or I want this. So what we have ControlNet, not the full version, because this is here the free version by ClipDrop. So we take the little tiny text-to-image adapter version of ControlNet. This injected weight tensors that we have, where we inject this into our UNet block infrastructure. We use the base model, and normally we have compute time between 2 or 3 seconds. So this is the input. Then I have some textual description where I describe what elements I want to have changed on this image, and let's see what is the outcome. Okay, first two, you see the background is always the same. I will tell you when I change the background. But here I modify here the texture of her dress. A little bit more metallic, or this version. You see here that sometimes when you create multiple images, and you have here whatever this structure is, even on the next images, if you do not have in the negative prompt that you make clear you do not want to have this on your arm, sometimes some artifacts go to the next image. So be careful about this. And sometimes when I said here in the input instruction, hey, change here the dress to a golden dress, the AI system decides that it will also change the color impression of the background, because this beautiful sunset or sunrise mood here goes better with a golden dress than this black or black bluish background. So sometimes the system tells you, hey, I also changed the background. Interestingly, you cannot change elements, but you can change the shape and the forms and the regularity or irregularity of hair. I thought, it's a nice hair, but can we have a little bit more non-professional hair? You know, a little bit more natural, curly something hair. And in this professional words, this was my input. The system generated this, you see. Interestingly, the system not only changed this, but only modified her address significantly and also took care about the background. Now, to correct the background, you would have to go in the negative prompt and say, hey, background should be stay unchanged or whatever. I didn't do this. And I left here, you see this here, stability AI here, this imprint here on the synthetic images. I left it. So you see, with each computer iteration, it changes slightly. So you see, this is really the outcome of the AI system. And I do this on purpose that you see those are synthetic images. Now, in the models, you find sometimes some dominant data sets. And in this model, what about the visual art type of science fiction and cartoon or whatever you say about this? Gee, there are a lot of models available. And you can say with a human face or with some drawings in a cartoon. So this is really available to you. But also, and here I said, change the shape of the dress to a minimalistic but ultra modern form of a dress, and the AI came up with this dress. Interesting. I think really nice. So you see, given my reference input image and my verbal prompt, you can really modify elements of your image. Sometimes you get it on the first try, sometimes you get it on the second try, and in the worst case, you have to create 3 images and you choose the best of the 3 images. Right. Now, let's change here the human model. Let's stay with the AI model with stability AI, Stable Diffusion XL. And let's see on a different pose. So this is our reference model. And now I have written here my modification in my human sentences that I inputted here in the prompt. I said here, change the expression. And you see here, this is our reference model, and this dress here is black and white. But you see here, the material changed. I think the shape changed a little bit. When I say, hey, change the toning, you see here that the complete impression here of this synthetic image changed. The material of the dress changed, whatever. If I go for a different shape here now and a different material of the dress, I get this image where also the face here has some modifications. I would go to the negative prompt and make sure that the face remains unchanged. Or even some crazy terms, I said, hey, increase the harmony in this picture. You're not going to believe it. This was the output here of the AI synthetic image. This is what the AI system is. This has more harmony to it. So whatever is your, here, my stupid commands, you see the LLM is able to translate this in a certain specific way. And I think it's some amazing outcomes for a free version. Here, the same model, but I used here different verbal commands. I used here a simplification command. And I think it turns out real nice. And you can have very slightly modification. And I did here a little bit with lightning. I don't know if you notice here the difference between those two, but it can be very subtle modifications. Or you go here with the length of the sleeve here, and I change here the material. And I say here, okay, you can generate this image. Or, and this is something that surprised me personally, I looked at these 3 images and said, oh, such a pity she's not smiling. And I said, what happens if I just put in, hey, put a nice beautiful smile on her face. And this here, image 4, is exactly the result after 2 to 4 seconds. So we do this with ControlNet text-to-image adapters, not even the mighty full gigabyte ControlNet, but this is just 100 to 200 megabyte of weight tensors that have been trained on this particular Stable Diffusion XL model, where I used the base model 1.0. So you see, you can start to have modification that you define. But again, it's not always on the first try the perfect picture. You have to go 1, 2, and maybe even 3 times. And then you choose the best version. Different kind of commands. I wanted to increase the coherence of the image, and this is what I get. Interesting. Then I said here, specific here, no material on one arm, and you see, this is the result here. Here I changed the lighting and increased here the back lighting. I don't know what you would call it in professional photographic terms, but you see the effect. Even some absolute no photographer can have here the power of the LLM so that his command is translated in a very beautiful image. Or you can combine multiple commands. And here on this image number 4, I had a combination of a free shoulder, change the material, change the hair from long hair to short hair. So you can have, with this ControlNet, really a powerful image morphing structure on a particular image that you have chosen, a particular type you have chosen, a particular AI model representative you have chosen, and you can start to modify even single elements. I don't know if this is better than Adobe Firefly. I don't know if this is more advanced than Adobe Firefly for your particular task, but just notice it is an alternative. If you know a little bit how to code, you can do it yourself. I experimented with the color space. I said, hey, can you shift here this in a different blue, more blue color space? You see this here. Or I said, hey, what about some strong backlighting? How would this improve here the profile? Or this is, for example, an error image where I show you what can go wrong. Look, here at this dress, there's something completely wrong with the dress. Or look at her legs. There's this curve here with the material. I don't know what this should be. So you get also this non-perfect images where you have some significant defects. But on the other hand, you can change the mood of an image. I wanted to have here this dress with a little bit more metallic shiver. And look, this is the image I get after 2 seconds. So I think it looks great. If you now take another option, and with ControlNet, you go with the shape ControlNet, where the pose of the model, you just draw a different pose, and the model is computed in this specific pose, as I showed you in one of my last videos, you have almost unlimited possibilities. And this is something I think that Adobe or Photoshop is not able to do. You can take this image and you can create, like you would have the camera positioned here at the wall, or the camera positioned at any different angle. So you can go for a 360-degree and take images of the same synthetic model and you, I think, generate some beautiful images for free. Yeah, with background now here you see the other lightning. I said, hey, can you put here a spotlight directly on her face? I don't know if you like this image or not, but you have the option to use here your human language to change your particular elements. And if you are a photographer, you are so much better than I am. Here on this image, for example, I said, hey, it would be nice to have some different background. What about we go here with a view to a green garden as the background, blur it, and you see this is the image generated. You can combine it with a lot of different options. You can use here a filter on the complete image, just on particular parts. Go experiment yourself. I think it is amazing what you can do with today's technology. And even if you want to change the mood completely, and here I said, hey, what about some evening mood with a nice evening dress? This is what has been generated. And yes, you guessed it. If you look here at the non-existent smile here, and if you look at the smile here, I combine it with different elements, and one of these was put a beautiful smile on her face. So this is what you can do today with technology. Just to show you, this was our original image, can be a synthetic image, can be a real image, can be an image from the person you love, whatever, do simplification. You can even play with the age. Yes, a very sensitive topic, I can tell you. But it's unlimited, the amount, because I don't know, but I guess on this planet, I don't know how many billion photos have been taken or in some photo cloud or wherever on the internet. So I guess you have a picture of a person every year or every month of her life. So the training data are there. And as I told you, if you go with a little bit more complex combination of effect with ControlNet, if you control the depth, if you change the material, if you change the lighting, if you want to have some nice smile, all the combinations are available. But please notice that the compute time might go up and you are not anymore in 5 to 10 seconds, but you are 20 seconds plus, of course. Great. Yeah, and the last, very short reference model. And now, this is an option I might cover in one of my next videos. As I told you, if you have on your phone the images of the person you love and you have 100 images or 200 images, or if you are married and you have 10 years of images on your phone, you have enough material to train your own AI model on this particular person. Look, this is here now a reference model, and this is, you can change the background. You can change anything. You have control about every aspect here of the visual representation, short hair, long hair, whatever is the material of the dress, whatever is the exact background. You just need training data. So maybe this will be one of my next videos. You can code, you can create, if you have enough images of, let's say, the person you love, you can create your own personal AI model if you want. And then, if you want, you can put this as an input where you create, I don't know, all the different beautiful backgrounds. So if you are an influencer and you want to be every day in different parts of this world, and you want really precise and beautiful and high resolution images, hey, there are opportunities coming up that will be really breathtaking. And yes, you guessed it, if we can say, hey, I want exactly the model in this pose, and then a second later I want the model, I don't know, reaches out with her left arm. Yes, you know that we go from here still photography to, I don't know, 1 second clips, and then 2 second clips, and then 5 second clips. So you can verbally describe the scene, the time series of photos you want to see. And all these images are then created with, for example, here, the perfect human model, the person that you love here, the images that you have taken. And you can create not synthetic images, but we can move from synthetic still images to very short video clips. But all of this will be a topic of a lot of videos that will come up in the future. I say thank you for watching, thank you for listening. I hope it was a little bit informative. You get an idea about what kind of visualization we can create for free if you decide you want to pay for a product, or you learn a little bit how to code and generate these images for yourself. And it would be great to see you in my next video.